Okay, this is 6.6, solving exponential equations. I like this lesson. To me, it's kind of fun. I know you may not think math is fun, so you may not feel the same way, but this one's not as hard as some of them have been lately. So we are solving exponential equations. First thing we're going to look at is when they have the same base. Okay, since we're talking about exponents, base is the big number. So base is the number. So for example, if I have 3x squared, base is the number down here, the exponent's up here. So if we look at this, I'm not going to explain it with this stuff because that looks super confusing. Actually, this part's not that bad. So 2 to the x power equals 2 to the 5th power. Since they have the same base of 2, they both have a 2 as their base, you can set your exponents equal to solve for x. So x equals 5, that one it's already done, bam, you're done. X equals 5. So let's look at some of these. So we have 3 to the x plus 1 equals 3 to the 5th power. So since they both have a base of 3, I can take and just set the exponents equal. So we have x plus 1 equals 5. Then we use that to solve for x. We subtract 1 from both sides. 5 minus 1 is 4, so x would equal 4. The next one, 6 equals 6 to the 2x minus 3. Since they both have a base of 6, you would set your exponents equal. Since there isn't nothing, we can clearly see that there is 1 6 there, so it would have an exponent of 1. So 1 equals 2x minus 3, so we would add 3 over. 1 plus 3 is 4, and then we would divide by 2. 4 divided by 2 is 2, so x would be 2 there. On C, we have 10 to the 3x equals 10 to the 2x plus 3. So we have 3x equals 2x plus 3. You have to get your x's together before you can solve, so you still look out front of it. That's a positive 2x, so we subtract 2x from both sides of the equal sign. 3x minus 2x is just x. That cancels, and you are left with 3. Okay, so far, these are not that difficult. You just solve with your exponents, set them equal. So go ahead and just try all 3 of these. You can pause the video to try those, and then we'll go over it. On number 1, since they both have a base of 2, we can set our exponents equal. 2x equals 6, and then we can solve for x. Divide both sides by 2, x equals 3. Okay, on the second one, they both have a base of 5, so I have 2x equals x plus 1. So before we can solve for x, we have to get our x's together. So I move it across the equal sign. This is a positive x, so I'm going to subtract it to the other side. 2x minus x is x equals 1. And then the last one, they both have a base of 7, so I have 3x plus 5 equals x plus 1. Again, I first have to get my x's together. 3x minus x is 2x, equals 1, and then subtract 5. 1 minus 5 is negative 4, and then divide by 2, and we get that x is negative 2 on that one. Okay, now we're going to solve them when they have unlike bases. So these are the 3 examples we're going to look at. So A says 5 to the x equals 125. So what we do is we look for something that we can make them have the same base of. So we have 5 as a base over here. Over here we have 125. So we know 125 is 5 to the 3rd power. We can make 5 our base because 5 times 5 times 5 is 125. Since they both have 5 as a base now, then you can set your exponents equal to see that x is 3. On B, we have 4 to the x equals 2 to the x minus 3. So on this one, we can make 4 a 2 because 2 squared is 4. Even though it has another exponent, you would take, we know 2 squared is 4. Put that in parentheses, then you have your other one, which is x. Because we have, in previous lessons, the rule is when you have an exponent raised to another exponent, you multiply them. So 2 times x, it becomes 2 to the 2x power. Okay, so that brings us to here. 2 to the 2x, now that they both have a base of 2, I can set my exponents equal. 2x equals x minus 3 Subtract this x over. 2x minus x is just 1x. And we're left with -3. So x is -3 on that one. Then on C, I have 9 to the x plus 2 equals 27 to the x. So on this one, we have a 9 over here and a 27 over here. Okay, so you first would probably try to look at 27. We can't make that 9. There's 9. Even 9 squared is 81, not 27. But I can make that 3, and I can also make 9 3. So on this one, we have to change both of them. 9 is 3 squared. So if you notice, I'm going to work that out over here. So I need a color you can see. So 3 squared to the x plus 2. Think of it like we know we have to multiply when we have an exponent raised to another exponent. So when you're multiplying that, think of it as if x plus 2 is in parentheses, because that 2, sorry, that was supposed to be a parenthesis, that's being multiplied is going to get distributed in to both of them, okay? So 2 times x is 2x plus 4. That's where we get this 2x plus 4 is the exponent here. Then 27 is 3 to the third power, and then we still have to the x power, so 3 times x becomes 3x. We finally have them both to a base of 3. So we said the exponents equal 2x plus 4 equals 3x. So we have to get our x's together. You would subtract this 2x to the other side. 3x minus 2x is just 1x, and you're left with 4. So x would equal 4. Okay, we're going to look at another example. So you're still doing the exact same thing, but now when b, or your base number, the big number, is a fraction, when it's between 0 and 1. So on the first one, A, I have 1/2 to the x power equals 4. So 1/2, 1 over 2, is the same thing as 2 to the -1 power, because when we write these with positive exponents, you put 1 over 2 to that exponent. 1 over 2 to the 1 is 1 over 2. So to work backwards, you would say, okay, the bottom number to the negative first power to the x. Then I could say -1 times x is -x. So since I got that one to 2, I can also change 4 to 2. 2 squared is 4. So once we get here, I can now set my exponents equal. -x equals 2. You have to divide by -1 on both sides to get rid of your negative. It just changes the sign of your answer. X is -2. Okay, on B, I have 4 to the x plus 1 equals 1 over 64. Scroll up some. So what we can do is first look at 64. Okay, we try to see, okay, is there anything I can change it to in relation to 4, maybe 2 if it doesn't work, but we can change it to 4. 64 is the same thing as 4 to the third power, so I can have 1 over 4 to the third power, and we now know since that's positive and it's on bottom, that's really a negative exponent, so 4 to the negative third power. This one's 4 to the x plus 1 power. So now I can set my exponents equal and solve. X plus 1 equals -3. Subtract 1 over, x is -4. Okay, so you are going to try, we're just going to look at 2 of these. Let's see, let's do 5 and 7. Give you one with whole numbers and ones with fractions. So don't worry about 4 or 6, try 5 and 7, and then I will go over it with you. Okay, from this section we did 5 and 7. So on 5, we have a 9 and a 3. I could probably make that one a 3. 3 squared is 9. Then anytime you have an exponent raised to another exponent, you multiply them. So 2 times 2x is 4x. Now that they have the same base, I can set the exponents equal so that we can solve for x. So I subtract this one over and get that 3x equals -6. Divide by 3, x is -2. Okay, on 7, this one kind of has several things. First thing, 1/3, I'm going to go ahead and write that as 3 to the -1. So then I can multiply those. So think of it as that's in parentheses and -1 is being distributed. So negative x plus 1. Then I can make 27 3 to the third power. So now that they both have a base of 3, set that equal. I'm going to get rid of the 1 first, but I still have to get rid of that negative as well. 3 minus 1 is 2. That just means you're dividing by the negative. X is -2. Okay, the last section we're going to look at today, and I hope it doesn't freak you out with me down here in the corner or distract you, but I did that so I can show you on the calculator for part of this. So we are solving exponential equations by graphing. Way easier than it sounds, okay? So these are the two examples we have. 1/2 to the x minus 1 equals 7, and 3 to the x plus 2 equals x plus 1. So the first thing we do, since it shows that these are equal, then we can say, well, y should equal this side and y can equal this side. Since they equal each other, we can say that. And what I mean by that, right here, we've split it. 1/2 to the x minus 1 and 7. From there, the calculator does all the work. So what we do on your graphing calculator, and I'll explain this again when I'm up at the board in case you forget, going over the problems. First thing you're going to hit is the y equals button, and it's going to pull this up. If you're like mine and you have stuff in there, you need to clear it out first. Clear it, hit the down arrow, clear it, okay? So what we're going to do, since we split it into two equations, that first equation, y equals 1/2 to the x minus 1, I'm going to type that in my first line. So when you have a fraction, you'll put it in parentheses. Open parentheses, that's 1 divided by 2, close parentheses. Then I have to the x minus 1 power, so hit your up arrow and do x minus 1. The x is up here. So to the x minus 1 power. Then just hit your down arrow to the next line. And the other one was just y equals 7. Once you get those, you can hit graph, which is over here. And it may take it a second, but it'll graph your two equations. I have them where my first one is more bold than the second one. Doesn't matter. Okay, so you just can't see my other one, but it's on there. So now what we do, we are going to, let me look at how they word it to make sure I use the right words. Yeah, the intersect feature. That's what I thought. Okay, so what you're going to do, now you're going to hit the blue second button and hit the button that says calc up above it in blue, or the trace button. It's going to pull up a menu. We need the intersection, so you can hit the down arrow to that, or you can just hit the number 5. And it's going to pull this up. It's going to say first curve, question mark, hit enter. Second curve, enter. Guess, enter. So you're going to hit enter 3 times, and it's going to say it intersects at this. They tell you x and they tell you y. Now, in our original equation, there was not a y. We just set it up to have 2 y's. So we're only worried about the x value. And it's like, I always say do 2 places behind the decimal. So negative 1.81 is what that would round to. And we would say approximately, because we did round it. So we use these little squiggles for approximately, negative 1.81. So that would be the solution. That's how we can do it by graphing. Okay, so on B, let's look at B. Same thing. It said, lost my place. B was 3 to the x plus 2 power equals x plus 1. So we can split it and say, so y equals this side, 3 to the x plus 2, and y equals this side, x plus 1. Now we go back to our y equals on our calculator, clear out what you have in there. Hit the wrong button. Down arrow, clear out the other one, and type in your 2 equations. So we have y equals 3 raised to the x plus 2, and y equals x plus 1. Now, you don't actually have to graph it. If you don't want, you can just go ahead and skip to the next part. I always like to just graph it to look at the graph, because we might not always have an answer on this one, for example. So hit the blue second button, trace 5, enter, enter, enter. And it gives us that. because if you look at your graph, I'm going to clear it and go back to my graph, they don't touch. So there is no solution if they never cross, okay, because there's nowhere that they touch, so you can't have an x that is a solution to that. So it just says they do not intersect, so no solution, and we could even do our little boop, no solution sign. Okay, so you're going to try, let's go ahead and do all three of those. 8, 9, and 10. You're using your graphing calculator to solve, and then I will go over it with you. This is the last one we'll do today. Okay, on 8, 9, and 10, you need your graphing calculator. So on 8, we're going to take and just split that apart, and I basically have that y equals this side and y equals this side. Since they equal each other, y can equal both of them. So then hit your y equals up at the top, and if you have information in there, clear it out. Okay, so on the first line, you don't retype the y, but I'm going to put y equals 2 to the x power. Then hit the down arrow to get to the next y. Then I'm going to type just 1.8. Once you get that, you can hit graph if you want. Give it a second to graph. I have mine where they're shaded different, one skinnier than the other. Then what you're going to do, you're going to hit the blue second button. Then hit, the trace or calc button. Then if you notice down here on number 5, we have intersect. Hit that because we want to see where they intersect. When you pull that up, it's going to give you some questions. So you hit enter, and it jumps to the other line, then hit enter again. You have to hit it 3 times, and it tells you intersection is at this point, x and y. We only care about x because that's what we're solving for, and we will round to 2 places behind the decimal. So we have 0.847, so that rounds to 0.85. So x, since we're rounding, we'll say approximately 0.85. Okay, then we get to 9. We go back to our y equals, clear it, both of them, and we type 4 raised to the x minus 3. Hit the down arrow, and then I have x plus 2. Graph, I'm actually going to go ahead. You don't actually have to hit the graph button. Just go ahead and hit that second calculate button and hit intersect. And give it a second to graph. Hit it once, twice, 3 times. Intersection is at this. And if you notice, if we round 0.99, it rounds up. So that becomes x equals -2, approximately -2. And I still wrote equals after I just said that. Approximately -2. Okay, last one, number 10. Go back to your y equals, clear it out. I'm going to put 1/4 in parentheses, raised to the x, like that. 1 divided by 4 in parentheses to the x. That lets the calculator know it's a fraction. Then I have -2x minus 3. Second, calculate 5. And it should look similar to that. If yours doesn't look just like this, it just means your window is set a little different. So hit enter for, do you want to guess the first curve? Yes. Guess the second curve? Yes. Guess intersection. And it's going to give us this page, error. Because if you notice on the graph, they don't touch. They're not going to. So there is nowhere. So this one has no intersection. Or you can't solve. No solution.